Alright guys, welcome back. I am bored, so let's just go straight from the top. Let's talk about some Newman projections, do some examples. I'm gonna get right to the point here. Newman projections are literally just a new way of representing molecules. You're gonna learn a bunch of different ways to represent structures in OChem. This is just going to be one of them. So for example, if you were given this structure. So let's say we were asked to draw the Newman projection. What would we do? Step 1, you need to stand. So you must stand. And you must stand either to the left-hand side or the right-hand side. Hold with me. I'm going to show you what I mean by this. So you're going to pretend you're a little person. You're walking in the park. Maybe you see a friend. If I stand from the left-hand side, I'm going to go give my friend a hug. Okay, pretend I have my two arms here. In this orientation, this would be my left hand, and this guy would be my right hand. This is me. Hey. So I'm going to give a look to my friend, where I'm going to say my little friend is this guy. So this guy's coming to give me a hug, where my right hand would match up with the wedge, and my left hand would match up with the dash. And then my legs, which point towards the ground, would match up with the isopropyl group. I'm going to forget about the back for right now, and I'm just going to draw the front. So I draw the circle, okay? And I see the dash and the wedge are in the up orientation. So I'm going to draw two lines in the up orientation. And then I see in the down orientation, I have that isopropyl group. That's going to be the easiest group to put in. So now my question is, okay, what group goes on the left-hand side and what group goes on the right-hand side? Left-hand side of page. Left-hand side of page. And this is going to be my right-hand side. Whatever group is touching my left hand will be on the left-hand side. So that would be the CH3 group on the dash. And then here, whatever is touching my right hand will be on the right-hand side. So this would be the iodine. So now, after you've established the front of the Newman projection, and we'll do another example where I'm going to stand from the right-hand side and see how this changes. Wedges are on the same side, and dashes are on the same side. So now I'm going to say, okay, well, where's the bromine? So the bromine is also on a dash. Well, the bromine is also pointed in the up direction behind the CH3 group. So just like that. And then the chlorine is pointed in the up direction right behind the iodine. And they are both in the up position, so this would be in the eclipsed form rather than the staggered. And then in the back, going downwards, I have this ethyl group. Ethyl group, meaning two carbons, carbon 1, carbon 2 attached. So this would be your Newman projection if I was asked to stand from the left-hand side. So what if I did the exact same thing, but I decided to stand from the right-hand side? Let's take a look at what happens. So I'm in the park again, and I see a different friend. But this time, I'm approaching them from the right-hand side. So this time, my left hand is going to be this guy. This is my left hand. And this dash is going to be my right hand. So dashes line up with dashes, wedges line up with wedges, just like last time. We can see that everything that was on a wedge touching my right hand in the first example is now on a dash. And the same thing goes for the left hand. Let's draw it. So we got the circle. Right now I'm staring at this carbon. I'm looking at this carbon. So this carbon is right there. And now I'm going to draw the same thing. So my left-hand side and my right-hand side of the circle. So what is my left hand touching? Well, it's going to be the thing on the wedge. So going up in the left-hand side is the chlorine group. And then on the right-hand side is going to be the bromine. So then what's going down? Well, going down is going to be the ethyl group down towards the ground. So then wedges line up with wedges, dashes line up with dashes. So if the chlorine is on a wedge and the iodine is also on a wedge, the iodine will also be on the left-hand side in the up position. And then we have the CH3 group, which is also on a dash, and it is behind the bromine. So we would just put the CH3, and then the isopropyl group is down towards the ground on the carbon behind the front carbon. So it would just point down towards the ground. So this would be the Newman projection if I decided to stand from the right-hand side. So what is our big overall bubble understanding here? We can see when I stand from the left-hand side, everything that is on the left-hand side will end up on the right-hand side when I stand from the right. And everything that was on the right-hand side will end up on the left-hand side. And anything that was in the front will be in the back. So here we see that the iodine and the CH3 group are in the front when I stood in the left-hand side. But when I stand on the right-hand side, the iodine and the CH3 group are in the back. All right, let's do another example. Okay, let's say we're given this structure. Step 1 is you're either going to decide to stand from the left-hand side or the right-hand side, or your teacher will tell you to stand either from the left-hand side or the right-hand side. You're probably going to indicate this by just drawing an eyeball, either on the right-hand side or the left-hand side. But I like to draw a person. I pretend I'm literally in the park. And if I was in the park, this would be the sky, and this would be the ground, where there's like grass. So just like if this was me and I was standing here in space, let's say I had 2 arms, my head would be closer to the sky, and my legs would be down on the ground, touching the ground. I'd be like walking on the grass. So same as my legs are pointed down towards the ground, that means this group would be pointed down towards the ground. And these groups would also be pointed down towards the ground. In the opposite direction, these groups would be pointed up towards the sky. So we are standing in the same orientation, even though that is a structure and I am a human. So now if I decide to stand on the left-hand side, and I draw my Newman projection, I'm going to draw a circle with a dot in it. The dot in it is going to be this dot. Pretend that this is my friend and I'm going to give them a hug. On this structure, I'm going to draw a line that splits the circle in half. And then I'm going to say the left-hand side of the split and the right-hand side of the split. This is going to be the sky, and this is going to be the ground. Let's call this carbon 1, and let's call the carbon right behind it carbon 2, which is going to be other carbon that is highlighted in the Newman projection, but we're not going to see it because it's going to be at the back of this structure. So now consider the person again. If I was just orienting myself like this in space, this would be my right hand, and my hand that's on the dash would be my left hand. So match up dashes with dashes, wedges with wedges. So the bromine on the dash would be matched up with my left hand, and the ethyl group on the wedge would be matched up with my right hand. So left goes on the left-hand side, right goes on the right-hand side. So pointed out and up towards the left would be the bromine. And then pointed up towards the right-hand side would be the ethyl group, just like that. And then pointed down towards the ground, matched up with my feet, would just be this CH3 group. So then we go all the way back to carbon number 2. So on carbon number 2, it's a little bit easier. So now we say wedges go on the same side as wedges, dashes go on the same side as dashes. First, I'm going to deal with this propyl group. Propyl means 3, carbon's 1, carbon 2, carbon 3, which is pointed up towards the sky. So up towards the sky in the back would be a propyl group. 1, 2, 3. C1, C2, C3. Did not add or drop any carbons. Good job. So now, on my wedge, I have the iodine group. But this iodine group is on a wedge, but it's pointed down towards the ground. I'd point on my right-hand side. I would have the iodine group pointed down towards the ground. And then on the dash, hence on my left-hand side, I would have the phenyl group pointed down towards the ground. And this would be my Newman projection. I really should have denoted these in the other color. Left-hand side would be purple. And then the right-hand side would be pink. So let's say I decided to stand on the right-hand side. Do the same thing, going to give my friend a hug. Now what is my left hand and what is my right hand? Well, now this would be my left hand. Hence, the wedge and the dash would be my right hand. So now, I'm going to follow the same procedure. Draw a circle. Split that circle in half. Pointed up towards the sky. Right in my face. This is closest to my face. Is going to be the propyl group. 1, 2, 3. Did not add or drop carbon. Good job. And then on the left-hand side, this time, so I'm going to do left-hand side. And then my right-hand side. On my left-hand side this time, it's actually going to be the iodine group. And where is it pointed? Well, it's pointed down towards the ground. So left-hand side, of the circle, pointed down towards the ground, is the iodine. And then right-hand side, pointed down towards the ground, is the phenyl group. So now on the back, on our left-hand side, hence the wedges stay on the same side as wedges, dashes stay on the same side as dashes. The ethyl group is pointed up towards the sky on the left-hand side, same side as the iodine, ethyl group. And then we have the bromine that is on a dash on the same side as the phenyl group, pointed up towards the sky on the right-hand side. And then finally, all we got is the CH3 that's pointed down towards the ground in the back. And this would be our Newman projection. We can see that everything in the beginning, when I start from the left-hand side, that was on the left-hand side, the bromine and the ethyl group, are now are going to be on the opposite side. So now the bromine is on the right-hand side, and the ethyl group. Then we can also see that the phenyl, which was on the left-hand side, is now on the right-hand side. So what was in the back switches to the front. What was in the front switches to the back. And then what was on the left-hand side switches to the right-hand side. What was on the right-hand side switches to the left-hand side. Hopefully this helps. Let me know if you have any questions down in the comment section. And also be sure to leave a like, save, and subscribe, maybe comment to my channel. Let me know what you want me to cover next and if this video was helpful. I hope you have a great night.